In our last video, we talked about, identifying a function, what a domain and range is, and how we know when a relation is a function, right? Because every domain has exactly one range. So functions are really just kind of like machines. I plug something in, I get something out. So now we're going to look at, now that we know a relation is a function, so from here on out, everything for the most part is going to be a function. We want to know, well, how do we write an equation using what's called function notation? How do I evaluate a function? And how do I find range when given domain? And then evaluating a function from a table and a graph. So let's just start right with function notation. What is it? It's simply another way. So another way of writing, woo, okay, I'm just gonna cross that out. Another way of writing an equation. Kind of like giving it a name. Okay, and so what we do is we actually just take out the y. So a lot of times we're used to just saying, like, y is equal to 2x plus 1. So what we'll do is we're actually going to take out the y and we're going to replace it with what we call, or how we say, f of x is equal to then 2x plus 1. So we've given it a name of f, the function f in terms of x. So right underneath, writing an equation in function notation. So function notation means really one major thing. We replace the y, like I just said, with a name such as f or h or g. Function notation allows us to name functions. You're going to be looking at multiple. So just practicing rewriting these equations in function notation. So number one, maybe instead of f, I'm going to do g. So I just do g, and then of x is equal to 4x plus 10. And then in number two, maybe I don't want to use g or f. Maybe I'll use h. So h of x is equal to negative 2.5 x squared. So you can see I haven't really changed the equation. I'm just changing where the y is. And then in number three, maybe you want to do j of x is equal to negative 2/3 x minus 1. So evaluating functions using function notation. So in function notation, f of 4 means the function f, so the function f in terms of 4, or when x is equal to 4. So in the past, we would ask you guys to evaluate an equation for when x is equal to something. So for example, if I've got y equals negative 5x minus 1, I'd say, okay, well, if x equals 2, what's y? So same idea, except for now we're going to do that in function notation. So in this example over here, okay, it says find f of 2. So find the function f for when x is 2. That's how you would read that, given that equation. So what I would do is I am just going to replace x with 2, and I'm going to solve. So that would give me negative 10 minus 1, and so my outcome is negative 11. So I would say the function f for when x is 2, I get out negative 11. So let's look at a few more examples below. So we have an a here. We've got the function h. So evaluate for when x is 2. So I would just do negative 4 times 2 plus 7. That gives me negative 8 plus 7. Okay, so my outcome is negative 1. And so I would say, oops, sometimes I get in the habit of doing f. So the function h for when x is 2, I get out negative 11. Or, sorry, negative 1. And b, I'm going to evaluate for when x is negative 3. So I'll do negative 4 times negative 3 plus 7. So that would be positive 12 plus 7. And so then my outcome is 19. So I would say the function h for when x is negative 3, I get out 19. Now this looks a little different, okay? Notice how this minus 1 is on the outside of the parentheses. So what that means is we're going to do that after the 4x plus 7 part of the equation. So I would do negative 4 times 2, so I'm plugging in 2 for x, and then I'm adding 7, right? That's all part of the normal equation, but then it's saying, okay, then subtract 1 from that. Okay, so that would give me negative 8 plus 7 minus 1. So then I'll go ahead and simplify that more. Okay, that's going to be negative 1 minus 1. Okay, so my outcome's negative 2. So I would say the function h for when x is 2 and I subtract 1, my outcome is negative 2. And then finally, I like this one because now we're not actually going to get a value, we're just going to get an expression. So evaluate for when x is x minus 1. So again, I just do negative 4 and then x minus 1 and then plus 7. And so then I would just simplify, I would distribute the negative 4, getting negative 4x plus 4 plus 7, and I get negative 4x plus 11. So I would say the function h for when x is x minus 1, I get out negative 4x plus 11. Okay, so let's go on to the next side of our notes here. So we're going to evaluate the range of a function when given the domain. So essentially, it's what we just did, but we're just doing it multiple times. Okay, so I'm going to plug in all of those domain values of x into this equation. So I'm going to evaluate, for instance, for when x is negative 1. I'm going to evaluate for when x is 0. I'm going to evaluate for when x is 1, when x is 2, and I couldn't fit this in here, but for when x is 3. So I'd get out negative 2, I get out 0, I get out 2, 4, and 6. So I would say my range, okay, is negative 2, 0, 2, 4, and 6. And that's it. So then in number 2, same idea, but now we're just going to plug that into the function g of x over here. So why don't you guys try this one on your own? So you should have done, okay, negative 3, insert or substitute a negative 6. And so let's see, that's 18 plus 1, so that gives me 19. And then we'll plug in negative 4, and that will give me 13. I'll plug in negative 2, and that gives me 7. Plug in, what's next? 0, and that gives me 1. And finally plug in 2, and that gives me 5. And so that would be, let's see if I can fit this in here. Yep. So my range would be, let's see, from least to greatest, I do 1, 5, 7, 13, and 19. So we can also get this do the same concept, but instead of being given an equation, I'm being given a graph. Okay, so I'm going to evaluate the function k. So this is my function k. For when x is negative 1, what's my outcome, right? So what I'm going to do is I'm going to go over to negative 1 here. Oops, I'm going to change that. I don't want a little saber here. Let's do this. Okay, so see when x is negative 1, so I'm on my x-axis. I'm going to drag my finger up. Okay, I've hit the point, and I drag over to where my y is. So when x is negative 1, my outcome is 3, and so that's my answer. Okay, so then when k is 2.5, so I go to 2.5. Okay, I don't see any points going upward, but I do see it going down, right? So at 2.5, my y value is negative 1. And then, okay, opposite. So now I know what my y value is. So I'm going to go to my y-axis. I'm going to find 5. There's no points over here, but there's a point here. So when y is 5, what did I plug in? Oh, I plugged in 1. So then x is equal to 1 for when my outcome is 5. Then on a table, so let's see. So they said evaluate the function h, and then for when x is 6. So when x is 6, my outcome is negative 3. And then for b, evaluate for when it's negative 11. So when I plug in negative 11, I get out negative 1. Now the opposite direction, what did I plug in when I got out negative 2? Well, I must have plugged in negative 4.